As many of you know, the Earth is changing rapidly due to increasing levels of carbon dioxide in our atmosphere. Carbon dioxide is one of the greenhouse gases responsible for global warming. Let's explain this greenhouse effect you hear so much about. Solar energy approaches the Earth as high-energy solar radiation. This radiation is reflected by the atmosphere, clouds, and surface of the Earth. What is not reflected is absorbed by the surface. The heat of the Earth is lost as longer wavelength infrared radiation. Greenhouse gases, including carbon dioxide and water, absorb this lower energy radiation. They bend and stretch, re-emitting the infrared radiation in all directions. Some of the re-emitted energy comes straight back to Earth. Together, greenhouse gases cause the Earth's surface to be about 33 degrees Celsius warmer than it would be otherwise. With more carbon dioxide in the air, the Earth's surface is warming. Fortunately, there are some natural processes which help regulate carbon dioxide levels. Terrestrial processes like plant photosynthesis take carbon out of the atmosphere, but most natural carbon sequestering happens offshore. The ocean's biological carbon pump helps regulate atmospheric carbon by trapping it in the ocean's depths. On the ocean's surface, carbon dioxide in the air reacts with water to form carbonic acid. Carbonic acid dissociates into hydrogen ions and an important ion called bicarbonate. This occurs naturally, but as more carbon is released into the atmosphere by humans, the ocean becomes more and more acidic, threatening the balance of a delicate system. Tiny microorganisms, called coccolithophores, are phytoplankton with hard shells. The organism's one cell is covered by as many as 100 tiny calcium carbonate plates called coccoliths. In 1 milliliter, or 1 cubic centimeter, there could be as many as 100 of these small organisms, accompanied by other important phytoplankton, such as diatoms, which come in a variety of shapes, sizes, and colors. Calcium ions from rivers and hydrothermal vents combine with the bicarbonate ions we talked about earlier to make the calcium carbonate in the coccolith shell. When coccolithophores are consumed by predators, like these small crustaceans called copepods, the calcium carbonate goes into the copepod's poop. Thanks to the calcium carbonate, the fecal pellet can sink to the deep ocean where it will remain for thousands of years. Without the coccolith shells, the carbon-filled organic material in this pellet will dissolve in the water column. The fate of our climate may heavily rely on this biological carbon pump, and more specifically the poop of these tiny creatures. However, with ocean acidification, the acid in the water may hinder the creation of calcium carbonate. If there is less export of carbon to the deep ocean, then less carbon dioxide will be able to enter the system at the surface. Ocean acidification may alter the strength and function of this biological pump, which has been greatly mediating the problem of carbon dioxide emissions for us all.